So I'm here today to talk about MySQL and Ceph. It's not exactly the talk that was in the abstract because I'm a lunatic guy and I didn't notice which talk exactly was accepted, but it's close to. I mixed up and did some rearrangement. So let's talk about okay. So who I am. I'm a physicist by training. Been working with MySQL back in 2007, 2008. I joined Sun when MySQL was bought by Sun, and I left when Oracle bought Sun to join Percona, where I have been since 2009 as a principal architect with an interest in highly available system and distributed system, which often goes together. Okay, my plan today. Who has ever used or been in contact with Ceph in the past? Oh, that's great. It's not that exotic then. Okay, so I'll go through Ceph 101 intro just to remind people that are not familiar with the technology. I'll discuss a few things that Ceph can bring to MySQL, and I'll introduce a project I have that I've worked but not completed yet, but I will show you what I have and what are the problems I'm facing. So, plan, Ceph intro. Ceph in general. What is Ceph? It's basically an object store, but an object store on steroids. It can do a lot more than a simple object store. It can be distributed. There are setups using thousands of nodes in large petabyte scale with 100,000 IOPS available. So it can be, the original design was on spinners to store a lot of big things, but it works fairly well with SSD drives and NVMe devices to provide a large number of IOPS. It is, by design, highly available, so it is resilient to most of the common failure of a node. It has multiple APIs to access the data, so there is a wealth of ways of putting data inside Ceph. And of course, it's a very popular OpenStack Cinder backend, although here I'm not covering OpenStack at all. It's a standalone approach. We use Ceph without OpenStack. So, versions. There are numbers and named releases. The named releases are the stable versions, a bit like what OpenStack is doing. It's in alphabetic order. So, Dumpling was before Emperor, which was before Firefly and Versailles, and etc. There's one release approximately per 6 months. So the last one was Kraken in January. Ceph has evolved a lot. There's been a lot of talk about RocksDB. It's included in Ceph in the backend storage now. So it's pretty cool. Node processes. So there's the OSD that handles the storage, the monitor, kind of cluster manager. So I don't know if there's people familiar with InnoDB cluster. So the OSD would be the data node, the monitor, the management node. So it's about the same architecture. MDS is something different that we don't use here. It's the file system. I have one at home, but it's not related to that talk at all. And there's some new proxies that are there to allow other ways of accessing. I'll discuss a few more. So the OSD nodes, that's basically the storage nodes, where the data, that's the thing taking your data and storing it. So, I just said that. It also performs replication. So when you define Ceph and define pools, I'll come back to that later, you define placement groups, which are kind of shards, and each OSD has a set of shards and connects to the other OSD that are part of the same placement groups and exchange data. along that. There's always one OSD that is master of a shard. It performs atomic operations, which is very interesting. And even though, as long as there's a Ceph journal, as long as the write is not too large and fits within the journal, it's perfectly an atomic operation. Typically, you'll have one OSD device per block device that you share. It could be more than one. An NVMe can throw so many IOPS that at least until recently we had to put more than one OSD per NVMe to fully use it. Okay, monitor, that's the monitor node. It's a management node that, like good manager, it's very important but doesn't work much for the production, just handles the cluster. So it's important for an HA purpose to have more than one, and since it's quorum-based with Paxos, you need an odd number, so 3, 5, so on. They are all active at the same time. They provide one very important thing. It's, again, I will use a similarity with NDB cluster. A client needs a kind of map of the cluster to use to know where to put the data directly. The monitor provides that map to the clients. And it monitors the OSD, so if it discovers an OSD is down, it will ask the other one, okay, somebody needs to pick up that placement groups and reshuffle the data to still offer a good availability. Maintenance tasks, so there are things like scrub inside Ceph that must be performed, and that's what, and those are triggered by the monitor. MDS, so that's the metadata server. It's used for CephFS, which is a kind of NFS server distributed across multiple nodes. It's really like an NFS server. So it's only one is active, and the metadata server, like its name implies, it's only for the metadata, so the directories and all that. It doesn't proxy any data. The data goes directly to the client, but it can only be one running. But if it goes down, the monitor can promote another one. Okay, so here a quick overview of how data is stored inside Ceph. So you have a client. Actually, all that is the client. So when it connected to the cluster, the monitor gave it a map of the cluster, and it pushed data, and the view of the client is like, okay, I push my 3 objects, they are there, but the library, as it moves the data toward the cluster, computes an algorithm that's called a crush map. It's the way it's it's hashing the data, and will move the data to their destination OSD, and then the OSD behind the scene will copy to the other node. Like OSD2 has object 1, but the 1 prime, which is the copy, will be moved to OSD1, and so on. So, and that is determined by the crush map directly. If there's any question, feel free to stop me. So now, inside Ceph, data is put inside pools. And pools have different configuration. You can have pools that are replicated, or the pools are not replicated for different purpose. For any HA purpose, you will need a replicated pool, but maybe if you already have copies like I will show, it's not always needed to have a replicated pool. Pool can be defined on different OSDs. So you may have SSDs, you may have spinners, and you define a pool on the spinners, a pool on the OSDs. And then you can play around and do a lot of work around that, a lot of stuff. A whole pool can be snapshot, although that's not common, except maybe for Rados directly. But you can snapshot and clone a pool. Clone? I don't know. At least snapshot. Replication is set at the pool level, so you cannot tell within a pool one object is replicated only once. It's the whole pool that replicates given the configuration parameter you set for the pool. And the access rights are also defined at the pool level. So Ceph use CephX. So you have a bunch of keys, you associated access rights with those keys, read, write, whatever. And those can, given the key you have, you access the pools you have the access to. And okay, I already talked about the placement group. So let's review here the architecture of Ceph. So you can put an object directly using librados. So it's like S3. Actually, if you use the Rados gateway, one of the gateway that are, one of the proxies or gateway that are available, the S3 API is recognized by Ceph. So it will accept a call from an S3 client and serve it as if it was an S3 storage system, or same with Swift. So those are objects, but one of the fun thing about Ceph is that an object can be changed in place. You can edit an offset in it. So that allows block devices. So RBD here are block device. So you can create a disk in Ceph and give it to either a VM like KVM that speaks directly libRBD, so it can connect in user space, or you have the kernel module in Linux that you can map a device and mount it. This is what I will use in my little demo. And CephFS is what I discussed. There is a file system that you can mount either by a Fuse module or a kernel module, and it's HA and NFS-like in terms of usage. All that is built on librados, and only objects are stored. So a block device is basically a concatenation of objects. On top of that, also, in addition to RBD for the block devices, you can have Linux NBD, Linux block device, and iSCSI proxies. So do a small show here. So you want to store an object in Rados. There's the Rados command line. So let's say here, I want to put my IBData1 file directly in Rados. So I have the path of the file, the name of the object I will put, the name of the pool, and I just hit return. And then I can list the content of the pool. Here I only have IBData1. I can get the object back. And of course, I can remove it. Those are very basic operations. RBD, that's for the disk. So Rados block device, mounting using libRBD or the kernel module. It can support snapshot, clone, resize, tin provisioning, and all that, which is very cool. So you create a disk with the RBD command line. So again, in my pool, create a disk of, let's say, 2 gig. Image format and image feature layering, those are to be able to perform snapshots and clone. You map the device, the RBD device that you created to the host where it is running. So it returns a block device, and then you format and mount the block device. And you can start using it. CephFS, so I already mentioned, distributed file system, Fuse kernel module, can be mounted in multiple clients. So basically, your mount will look like that. That's a copy paste from my home server. I'm hiding 3/4 of the 3/4 of the secret, and then you have the mounted point there. So for the deployment of Ceph is rather tedious. It's not easy. The documentation use Ceph deploy, just rather cool. If your cluster is not too large and you're learning, it's okay. But if you're deploying on, let's say, tens of nodes, it's a lot, it's keyboard intensive. So I suggest you have a look at Ceph Ansible, which is part of the Ceph project. It's one of the developer of Ceph that is working on that. It's still challenging. I used it for my little environment I'm using here, and wow, that was, it's just 3 nodes, so I wasted time, but at least I went through the steps, and there's so many options and configuration that you have to deal with, but it's still, I could see the benefits over a large cluster. Okay, so that's my home cluster that has been up for about a year. Those are not Raspberry Pis, but more powerful. So they are using Samsung Exynos CPU, so 8 cores, 2 gigabyte of RAM, gigabit Ethernet, USB 3, and those are little laptop type USB drives. So, and that works, has been up for a year without any failure, so it's pretty interesting. Okay, now what can we do with Ceph for MySQL? So let's say it would give a scalable storage, which kind of obvious. The possibility to leverage, if you have sufficient concurrency in MySQL to use a lot of threads, you could potentially have a lot of IOPS, even if you're on Spinner. I did testing with Red Hat on 48 OSD cluster with spinners, and we got nearly 100 IOPS per disk, and those were 7,000 RPM, so we pretty much use everything. So, but we needed a lot of threads. It's very efficient for backups. You snapshot, clone, and so it's very, very quick and efficient. It allows you to move a database from one node to another, like what you would do with an OpenStack virtualized environment. And so, but all those are basically what you can do with an iSCSI also. It's very similar in principle. So in terms of storage, it's very efficient. So you can tin provision slaves. All the servers, if you have, let's say, a master and a set of slaves, don't need a full data set. They need just room for the pages that they change, but they don't need to have all the data. Let's say you have a 1 terabyte data set. All the slaves don't need 1 terabyte of storage with Ceph. Same with XtraDB cluster. You don't need to have all the data everywhere, just a master copy and snapshot clones. So I'll give you an example here. So you have a master which has an RBD disk, replicated, all that, and you want to spin up slaves. You snapshot and clone and mount the clone. And then all the storage or the pages or the stuff that changed since. That will grow over time, but once it's too large, you trash and recreate it. It takes like a few, we'll show you, it takes a few minutes, a few seconds. So an example, complete with more details. So let's assume you have 3 physical servers running MySQL, the OSD on each node, and the monitor. So that's fully HA. Every server has 1 terabyte of storage. The data set, let's assume it's 500 gig. So normally, each server would have 500 gig of data. So there will be a usage of 1.5 terabyte. Now, in a tin provision scenario with 3 nodes, you would have the master would have a replicated copy. So it will use twice as much data, but the slave would barely use anything if the write load is not very high. So let's assume it's a rather light write load and mostly a read load. The slave will have very little delta, so they will not have need a lot of storage for those pages. So, and also, which is very interesting, the slave are just there for read. So what they have changed on disk, if the slave server crashes, you don't care. So you don't need to put that data inside a replicated pool. It can be a non-replicated pool. And it can also, that's a bit tricky to do, you can localize a pool to one specific OSD node. So if, in order to have saved the network hop when you, for the slaves, when they write their delta pages. Of course, like I said, the delta will grow over time, but when it's too large, you just reprovision. So let's see if my demo can work. Is it the right one? No, it's not the right window. Here, okay. So I have 3 nodes. So Ceph node 1, node 2, and Ceph base. Should be node 3, but I forgot to change the name apparently. So we have on Ceph node 1, there's MySQL running. It's the master. If I look at RBD show mapped, it has the image it uses is master. It's in the MySQL replicated pool, and it's mounted on RBD 0. So if I do mount, so RBD 0 is mounted on valid MySQL. Now I want to add a slave. So I wrote a script that is available on GitHub. I wrote many scripts, one to do backups, one to provision a slave. So here, more. So the make me slave takes a bunch of arguments. One is the master IP, GTIDs, the root and the root paths of the master to set up the backups, and the replication credentials to use, the pool to use, which here will be an unreplicated pool. So in order to do it, I'll just execute. You see, it will basically SSH the master, perform a snapshot, clone the snapshot, map a device, mount a device, start MySQL, set up replication. Inside the snapshot, there are the replication coordinates. So, okay. So we have MySQL running now. Always hard to type when you look backward. Okay, let's see. All right, it's connected, it's replicating, all right. So let's see what we have in terms of storage now. RadosDF. So, see, there's a sysbench database installed, so the master image is the only image in MySQL rep, and it's using 311 megabyte. In MySQL onrep, the only RBD image is using about 50 meg. So let's see now if I start some sysbench work on it. There's my sysbench command. It's always hard to read when, sysbench run. So it will run for, I think, 15 seconds, not too long. So if I monitor here, the size will not change right away because MySQL is buffering the changes and writes them when it's flushing. But it's starting, so yes, it's done. We'll flush its pages. I can flush. Okay, it's doing it. Okay, so see, the space usage grew a bit, close to 100 meg, above 100 meg. So here, of course, I ran sysbench, which updates all over the place, so it's right intensive apps. But I mean, if I wanted, I just go here. I diverge too much, so I could cron every day, something like that. You do it again. It scraps, deletes the previous snapshots, create a new one, and again, if I go here, I'm now back to about 50 megabyte. So that's the trick. Any question?
Yes, it's possible to put outside MySQL from the Ceph now?
Absolutely. Yes, yes, yes. Here I just showed a kind of hyperconverged setup, but yeah, you could have a Ceph cluster with 100 nodes and HA nodes for a set of MySQL nodes, and yes, it could work absolutely. And of course, you can use a virtual environment.
And for store the database, is better set the replica lead?
So here I am using 2, but 2 is okay on SSDs and NVMe. On spinners, the recommended value is 3 because it depends how you configure your pool. You can, by default, if an OSD is out, everything will rebalance. So there will be a lot of network traffic. You will overload some devices. The spinners are very easy to overload. So you may have a degradation of performance. That's why they prefer to have 3, and spinners are more likely to fail at the same time. And it's really based on experience of Red Hat. They say on spinners we had too much problems with less than 3. Having said that, you can also choose to set the OSD. There's a flag to do nothing if they're out. So if you restart an OSD and you don't want Ceph to start moving stuff around, you set it to no out. But then you're on your own if you do that. If you don't monitor and more than one node goes down, you lose data. So if you have strong monitoring, strong procedures to react upon a failure, you could do that. Otherwise, leave it to no out, and Ceph will manage to minimize the risk. Yeah.
So is there any performance implications because this keep track of all the changes, right? Suppose if you write something in the slave side.
Sorry?
Essentially a snapshot on the slave.
Yes?
Suppose if you write something in the slave, then it needs to keep track of all these changes, right?
Yeah, okay, so if you write something on a slave, let's say by replication, by default, data is not necessarily localized. It could be on any of the 3 nodes. There are options. You could trick the crush map to localize it because there's primary affinity. You have no replication, and you can set the primary affinity of a pool used by that slave only to be on that node. Yeah, it's possible. It's a bit tricky, but it could be done. And but otherwise, it's just sent to one of the 3 nodes. Okay?
What about the master side, something is updated, right? So now it has to come to the slave, and essentially since it's a snapshot, now those blocks are changed, so it has to keep track.
Yeah, it's done by Ceph directly. Yeah.
Does it have
It's rather lightweight, considering, it's exactly what ZFS is doing. It's copy and write. So you have a transaction, not a transaction, but kind of the snapshot has been taken at a given marker time or whatever, and if it will look within its current image, if there's an error and a version after that of the page, we'll use that one. If there's nothing, it will just read from the master RBD device directly. But it will read the snapshot, the version before. Not if the master updated it, it's fine, it's after. So it's because of the snapshot, Ceph will preserve the previous objects.
So here also they have like snapshot and the clone. Like ZFS, they have like the snapshot as well as the clone of the snapshot.
Yes. It is a clone. Yeah. I have to. So I create a snapshot. I have to protect it. ZFS will do that automatically, and then I clone it.
And use that clone for that.
Exactly. And so, like I said, you can use a different pool for the clone, for the updates.
Right.
So you could have the master on SSD devices, the slave on spinners or whatever. It's very flexible. Okay, XRDB cluster. So you could do the same with XRDB cluster. I don't recommend using unreplicated pool because you never know with XRDB cluster which, if your master, the one serving the master replicated image is down and you lose the cluster, you will lose data. But yeah, so I have, again, I wrote the WSREP SST Ceph script and it just works. I had to ask the PXC developers to add something because basically before Galera starts, there's a CD to the directory, and after that I need to mount it. So I was running under the mount point, and so it was always failing. I have to reissue after the SST a new CD. So I just add that again. Why? So for the snapshot. So, okay, so going further, what time is it? I just want to make sure I'm not out of time. I think, okay. So the next step I would like to do is have MySQL talk directly to Rados. Why use a file system and a block device while you cannot do it? So you could do directly. So InnoDB pages are essentially objects. Why not store an object that is identified by a table space and an offset? So it could go straight to Rados, would save a lot of potentially contentious layers. Rados is an object store. Okay, that's basically what I just said. Galera, with Galera and group replication, we could have slaves that share the same pages that are read-only and receive from the replication stream of Galera or group replication the updates, and either the updates in memory or they just trash their page and reread from disk. Probably updates in memory would be faster, but essentially we could do that and never write to disk, anything, you just read. If you have to flush something, you discard. The master will do it. So exactly the same principle as OOA. That's exactly the implementation. When I started looking at doing this, all the places that would be impacted, I realized, that's why they are not using the change buffer. Yeah, of course. You cannot easily, yeah.
What kind of delay do you see when you use this?
When you use Ceph?
Yeah, so have you tried that? Better performance testing?
I mean, when you access the data, let's say you run a regular MySQL instance, the overhead of the IOPS is about the same as iSCSI. It's a network hop, so depending if you have 10 gigi or 1 gigi, you will be a bit slower. On 100 megabit, it's very slow, but it does work. It's okay. On high IOPS, let's say we did benchmarks, so we reach on a single instance more than 10,000 IOPS, and we had many. So believe me, the OSD CPUs were maxed out completely, but they improved a lot with Kraken. They use now an asynchronous messenger for the nodes, and that lowered the load. With TC-malloc, it helped a lot, the newest version. So.
Could you safely disable doublewrite? Could you safely disable doublewrite?
If with Rados, I could. Yeah, because it's an atomic operation. So if you can edit in place an object, but behind the scene, what Ceph is doing, it's copying a new version. So exactly like what ZFS would do.
So you probably want to use larger page sizes.
Exactly. I would probably use that. And on top of that, you could use transparent compression. Punch hole is a no-op here. I mean, instead of, let's say you have a 64 kilobyte page that you compress to 18, you don't have to do a punch hole. You're saving 18 kilobytes. So ZFS, or not ZFS, Ceph will handle storing that object, but there's no file system to punch. So.
Well, you're also with the larger page size, you're sending less requests across the network, so you're using less latency time.
You will save some of the IOPS, yeah, and some of the network round trip.
So have you got this running, sir?
Huh?
Have you used this?
I compiled, but I have SegVec. But realized that I watched the schedule last week, and it's not the talk I thought was accepted. I had prepared the other one. Oh, shoot. Okay, and by the way, it's done for RocksDB. Inside the RocksDB tree, there's you probably know that, there's the RocksDB can store its pages, its SSD files to Ceph directly, Ceph Rados. So, and it's quite rather funny, the OSDs now in Kraken and the newest version also use RocksDB to lower the number of writes, because before that, Ceph had a journal, so writes to the journal, then asynchronously write in place, so it was a write amplification, and they use now also RocksDB to do the kind of same thing. The small writes go to RocksDB and eventually are integrated.
Do you know if anyone's working on any kind of custom replication based on this?
On Ceph?
Yeah, where basically you don't need to ship bin logs, maybe you can use Ceph as...
Yes, Ceph Kraken supports replication. I've never used it. I've just noticed it's basically, I think it's OSD to OSD. So if you need to set up another Ceph cluster in a remote DC, they connect to the other OSD. I don't know the details how they do that, but so, and I don't know how synchronous it is or consistent it is. I mean, you have to keep in mind that Ceph was mostly designed to be an object store at the beginning, and if you're storing big objects, you don't necessarily need to be consistent, but for a file system or a block device or database pages, that could be disastrous. Okay, RadosFS is an implementation of a pseudo file system, very simple in Ceph, that supports the atomic operations. So I thought, that could save me a lot of work instead of reinventing directory structures and inodes. It's already done, so I choose that. It writes in chunks that you define. For a file that you open, you define the chunk size, so the page size would be awesome. It allows me to abstract all the file system things. Modifying InnoDB, so most of the changes are located in OSO file. So it simplifies a lot of work. So I went through and changed it. Yes.
Basically, InnoDB will have lots of random I/O. I mean, InnoDB basically will have a lot of random I/O that we will
Absolutely.
put the data back and forth through network because we use the remote storage.
Yeah.
In that case, then how come the performance will not be hurted? I think that hurt will be.
Yeah, but think about what's the ping time on a 10 gig network? It's half a millisecond.
Yeah, half a millisecond.
Okay. On a spinner, so 10 minutes? Yeah. So on a spinner, the average latency is probably 3-4 millisecond on 15K RPM,
Yeah,
so it's much
due
bigger.
to the nature of InnoDB, such kind of thing will be amplified,
Yeah,
right? Because one simple I/O will do a lot of back and forth through network.
absolutely.
We
Yeah.
have to talk with the InnoDB engine.
Yeah, but it's exactly what you would do on iSCSI.
Yeah.
Yes, it's the same thing. So you have to opt, yeah, for every page you do a get and put, and yeah. Okay. So initialization, where I define the pools to use and all that, and server or start. I don't know if some are familiar with the MySQL source code. Just Oracle cleaned up a lot of things. It's much easier now. And it's much C++. I had to, so last week I finished my stuff, tried to compile, and realized, inside row merge and row sort and things like that, when you're generating the online indexes, you're using a lot of temporary tables. And instead of using OSO file that in my implementation is now an object, I remapped to an object. It's now, for that part, I use an FD directly, an integer. So I just had to shovel a few things to use the local file system for the temporary files. The status, so it's coded, it compiles correctly, but I have a segvec and lib-rados. It's exactly not where I would have expected. In my code, yeah, it's very possible, but like my code finish here, there's 10 calls, and it's there, the segvec. So I have to instrument that part of Ceph, and believe me, if you have ever compiled MySQL, compiling Ceph is not the same. Yeah, seriously, you do CMake in MySQL, it just work. You need some packages, but it works. With Ceph, you have a list of dependencies, you install all that, and install a load of packages, start CMake, it stopped like 2 lines, missing library. I just installed the dependencies. So it's not a piece of cake. So I have to find out why. It's probably a version of Ceph. I just changed today. I haven't tested it. So if somebody is interested in helping, it's all on GitHub. So I'll be glad to help. So anyway, that's about the project. It's more exotic things. The tools, if you're interested for the backups, the SST thing, the make me slave script, they're all on my GitHub too. So, question?
So I'm thinking about your comment about comparing this to Aurora.
Yeah.
And we did some load testing against Aurora recently, and it was terrible.
It depends on the workload.
Yeah, our workload was very write-heavy,
Mm-hmm.
and Aurora was not able to keep up. So I'm wondering if your implementation is something kind of related, kind of similar.
Yeah.
Would it have the same weakness?
Do you have many secondary keys
Yes.
on a working set that doesn't fit in memory?
Yes.
It's terrible.
Yeah.
That's the worst case scenario. Because there's no change buffer. You can't believe how the change buffer is a cheat that InnoDB is doing. Remember, I don't know if you were there a few years ago, Mark Callaghan showed graphs. Inserted many billion rows in the database with, it was, one curve was InnoDB, the other one was PostgreSQL. And his point was, look at the change buffer. InnoDB finish, it's many billion rows, like a day and a half after the start. 3 months later, PostgreSQL was still doing it. It's not because it's not a good database, it's because InnoDB cheats like crazy. They're all buffering those things and applying when it sees the page, and so. Yes?
So obviously there's no built-in support for RDB replication across geolocations except for clusters, but is there support for taking a snapshot and moving that to a separate cluster?
I have no idea. So I noticed the feature, like I said, I never used it, and so. Other question? Yeah.
I have a sector club, but deploy other guy. So many problems performance.
Oh, yeah?
Because the network is only one.
Okay.
I see
yeah.
The network.
Yeah. You can saturate it at a few thousand IOPS.
Separate public and private, and 1 gigabit is
Yeah. Seriously.
don't work. I mitigate with commit in 1 minute and in etc fc tab.
Okay.
Yes, so lovely. I view latency problems, no throughput problems.
Okay. Latency on the IOPS. Oh, yeah. We, with Red Hat, we spent a lot of time last year working with them on a reference architecture for databases. Like all their things are geared toward bandwidth. And we don't care about bandwidth, we want IOPS. So we had to do a lot of things, and it's CPU intensive on the OSD, so don't be cheap on the CPU. It's network intensive, but not as much as the bandwidth. It's really the throughput. So I had people say, we'll just use a bonding of multiple gigabit, but you don't. You still pay a lot of latency.
In the normal use, never full the throughput.
Yeah.
I can test with Netcat and the DD. Yeah.
Yeah.
No throughput problem.
Okay. Another thing, like that's a general statement. When you have a storage that has a latency, it can be a spinner, it can be iSCSI, it can be Ceph. Have a look at the parallel double write buffer. When I was doing my test, I had so many problems with the double write because it's a bunch of slots, and once they're full, you're waiting for the ops to complete. But you have a Ceph cluster at the other end that could handle thousands of IOPS in parallel, so you don't submit enough. So I went back and asked Rados to do something. He implemented the parallel double write buffer, so every cleaner threads has its own. So instead of, let's say, submitting 100 IOPS, you can submit 100 per cleaner threads. So it more than tripled the throughput. We start to see, it was very frustrating. You try to push and nobody's working. So, and then with the parallel double write buffer, it raised to a decent amount. Okay, I think we're out of time, so.